5.2 is looking at solving exponential and power equations. Those are two different types of equations. I'm going to show you how you can tell the difference between the two. An exponential equation has an x in the exponential spot. A power equation has a number in the exponential spot. So let's do a couple examples really quickly. A lot of these that are picked because of the simplicity of being able to guess and check. If you're solving by inspection, you're using your prior knowledge of exponents and the base to figure out what value would work for x. For instance, if I had to ask you what power of 2 gives you 8, well, 2 times 2 times 2 is 8, right? 2 times 2 times 2 equals 8. So that must mean that x is 3 because there were 3 times I had to multiply 2 by itself. If you look at the next one, what power of 4 gives me 16? Hopefully you're thinking 2. 4 to the second power is 16. What if you end up with something like this, asking you what power of 3 would give you 1 over 81? Well, I can tell you this. I can tell you that 81 is a multiple of 3. But how do I make it be down here? Okay, well, first of all, 3 times 3 is 9, times 3 is 27, times 3 is 81. So I know that 3 to the 4th power equals 81. If I wanted to figure out how I could change this so that it becomes 1 over 81, I implore you to remember what it is you have to do to the exponent to make it so that you have to move the power to the other side of the fraction bar. The exponent would need to be negative. That way you know, in order for this to be positive, you'd have to move it to the other side of the fraction bar, resulting in your answer being some kind of rational thing. So for this one, x is going to be negative 4. If you see a fraction, chances are you're going to have to consider that that exponential might be a negative number. What power of 10 gives you 10,000? I'll tell you a really good trick. If you count how many zeros, 1, 2, 3, 4, that's how many, that's the number that you need to put in the exponent spot. 10 to the 4th power is 10,000. So t must be 4. On the next page, we were being asked to solve for the unknown variable. Doing all of the same things that you would do if you were solving an equation, you're going to try to isolate your power first, and then do either by inspection or something along those lines. You're going to try to take it even further. For instance, I would divide both sides by 5 to start isolating my power. 45 divided by 5 is 9. I had to look at that. What power of 3 gives you 9? The second power of 3. 3 squared gives you 9, so t must be 2. If I look at the next example, 2, I need to isolate my power, so I'm going to have to subtract 5 from both sides. 3 to the power of c is going to give me 27. Just so happens that if I multiply 3 by itself 3 times, that gives me 27. So c must be 3. For number 3, if I want to isolate my power, the first thing I'm going to do is add 34 to both sides. Then I'm going to divide both sides by 6. And then I ask myself what power 4 gives me 16. 4 times 4, or 64. 4 times 4 is 16, times 4 is 64. So x must be 3. If I multiply 4 by itself 3 times, I will get 64. Go ahead and try this one real quick. Pause it while you try it, and then come back. I'm going to start by subtracting 9 from both sides. And then I'm going to divide both sides by 640. I could put this in a calculator, but what I'm actually going to do is simplify as much as possible. I know that 20 goes into itself once. It goes into 640 32 times. Yeah, 20 times 32. I need to figure out what power of 2 would give me 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that is the fifth power of 2. If 32 is on the other side of a fraction, that indicates that my fifth power is actually going to be negative. That's how I'd move it to the other side of the fraction. So t must be negative 5. Recall that the power equations have a number in the exponent spot, like x squared equals 100. When I'm solving this, be aware also that if you have an even exponent, that you would have to use what we call the Plinus sign. And the Plinus sign looks like this. It's a plus and a minus sign, and I will explain why. If I wanted to know what needs to be squared to get 100, I can take the square root of both sides. The square root of 100 is 10. But I have to tell you that that's not the only thing that I can square to get 100. 10 times 10 is 100. Negative 10 times negative 10 is also 100. So what I do is anytime I find myself in a position where I'm simplifying a power and trying to solve for whatever the base is, and the power is an even number, then when I get my answer, I must put the plus sign and minus sign here. This is indicating two separate results. One is the positive version of 10 and one is the negative version of 10. So there's actually two solutions here. Solve x squared equals 100. We already did that. I'm going to show you what it looks like. Square root, minus x equals minus 10. I want you to remember, anytime you are canceling a square, you would cancel it with a square root. What's canceling each other are the 2's that are in this spot and this spot. But what happens if there's a 3 in the exponential spot? I can tell you this is an odd number, so no Plinus sign. This time, if I want to get x alone, I'm not going to take the square root of both sides. I'm going to take the cubed root of both sides. Now, anytime I want to put this in my calculator, one great way to do that is to raise it to the power of 1/3. That's another way of writing that. I believe that the cubed root of 125 is 5, because 5 times 5 is 25 times 5 is 125. So, in this case, x must be 5. What happens in a situation like this where it becomes really difficult to figure out by guessing and checking what x could possibly be? I can tell you this. Anytime I have a number, say the number is 5, and I want to cancel this number out, I can multiply it by its reciprocal, which basically cross cancels the 5's, and it gives me 1. Now I want to change this exponent so that it's 1. I would need to multiply 7 by its reciprocal. So the only way I can do that really is if I raise both of these to another power. If I do that, then I can multiply something with the exponent. The power is going to be the reciprocal of the exponent that I'm trying to cancel. I can do whatever I want as long as I do it to both sides. So x equals, and then this is what I'm putting in Desmos, 78125 raised to the power of 1/7. Here it is straight from Desmos. 78125 raised to the power of 1/7 is equal to 5. page 76. Here are some more power equations. Remember that you need to start by isolating your power using whatever techniques you've used. I have m to the fourth power equals this thing up here. If I want to cancel out that fourth power, I have to raise the power of each side up to 1/4. That allows me to cross cancel my 4's. M is alone. This is what goes in my Desmos. 22509.375 divided by 150, raise the power of 1/4. There it is, folks. So I put this in the calculator. My result is going to be 3.5. I want you to take a moment, try the next two examples. Have faith in yourself. They look harder than they are. And then come back and compare your answers with mine. Okay, looking at the second one, I'm going to add 17 to both sides. Divide both sides by 3. And then I'm going to raise each of these to the power of 1/5 to cancel out the exponent next to t. In my calculator, 1024 raised to the power of 1/5 is, surprisingly, 4. T equals 4. On the next one, if you're going to go ahead and try to solve for m, the first step is going to have to be getting rid of the 16. So I can multiply both sides by 16. That will allow me to cancel this out. Now I have 2m to the 5th plus 38 equals 32.75 times 16. I'm going to subtract 38 from both sides. And then I'm going to divide both sides by 2. And then I'm going to raise both sides to the power of 1/5 so that I can go ahead and cancel out that last fractional exponent. So this is what goes to my calculator. One fell swoop, it's going to give me the entire answer. So let's go ahead and do that now. That's going to come out to be 243 once I put that in Desmos. Okay, this wraps up video number 8. I believe that is what it is. I shall see you in the next video.